So whenever you have a question, just feel free to answer to question. We give you the answer right away. I come with the microphone right to you. Mr. Hieke, the slogan of H-TEC Systems is "Hydrogen is now." What does it mean, it's now? Do you mean the Now GmbH, who's giving funding projects? Or
It's a funny coincidence, but in general, you see, when you're here, you see that the hydrogen is basically state of the art. It's in every discussion we are having already, so we really believe that it's time to really talk about hydrogen, to put it into effect, to have projects, and to get it on with, yeah?
Hieke, to 60% you belong to GP Joule, which is focusing on the production of renewable energy. But renewable energy has a problem. It's volatile. Sometimes the sun is shining, sometimes the wind is blowing, sometimes not. So in the end, we need a long-term storage, which could be hydrogen.
Yeah, that's true, especially because with an electrolyzer, you separate the conversion of the storage itself. So to make a distinction between the battery, which you can store basically and reproduce the energy in the same system, with hydrogen you have it separated from the converter to the power storage. So the size of the storage is independent from the maximum power you can put into the system. So it gives you a high flexibility for long-term storage for days, months, weeks, anything.
So, but where can we store the hydrogen then? You can just easily produce it with your electrolyzer, but we have to store it somewhere.
It's either in standard hydrogen vessels, which are on the market since decades, or even pipelines in small areas, yeah.
Mr. Hieke, H-TEC System manufactures mass-produced PEM electrolyzers. That's what I read on your website. But the mass production does not happen yet.
It's
that's possible. It's not a really production line that you produce like 10,000 electrolyzers a year.
I wish we would, but yet we don't do so far. But in our whole development of our electrolysis stacks, we made one thing clear from the very beginning. We want to be ready for mass production. So everything is made in a way that it can be assembled by a pick-and-place robot, for instance.
But you believe, obviously, in a mass market for electrolyzers.
Exactly.
What are the conditions you need to come to such a mass market?
It's not a technical question at all, I would say. It's more about the environment you have to get your investment back in an application that has a business case that works in a couple years' time. And currently, the environmental conditions for taxes for the power supply is not ready yet to supply the power to the electrolysis in a way that it supports the whole energy system, energy transforming, and also the power storage part.
So, electrolyzers can transform renewable energy, any kind of energy, actually. But in your case, in your projects, it's renewable energy can produce hydrogen at a certain efficiency. It just needs water for that, but it loses a little bit of the electric power. How much does it lose?
It really depends on the operational condition. We have a broad spectrum of operational conditions which also vary in hydrogen production, and secondly on the efficiency. So meaning in partial load the efficiency is quite high, it goes up to 80%, and the remaining losses are heat, about 15%, and at nominal we are about 75 to 20 to heat, and if you're running on full power it's more 60 to 35. So broad spectrum, many opportunities, but the losses, the heat losses, are in hot water at a temperature of 65 degrees, which can be used in district heating to heat up the water.
So it depends. The efficiency depends on the maximum power you use for your electrolyzers.
Exactly.
It starts with 60% up to 80.
Yes.
Reach?
Yeah.
Okay, and the rest will be heat, which is it's a heat producing process, the electrolyzing.
Yeah.
And in your projects that you're following, you use actually the heat.
In
The
some,
65
in some,
degrees.
in some projects where there is a need for heat, it's been integrated into the heat grid. In others, we have to use a ventilation to get rid of the process heat.
Which is a shame, isn't it?
Which is a shame, yeah.
Okay, but when it's close to some housings, you can just use the heat and
And also use the heat for cooling, because if you have an absorption cooler, it's also an option to have a building cooled down to some extent.
So the electrolyzer produces hydrogen, it produces heat, and it produces hydrogen at a certain pressure.
Yeah.
So what pressure can you is your output?
It's variable, but up to 30 bar. That's the maximum rating.
So 30 bar is quite something. You know, you can already store it at 30 bar. You just released your megawatt PEM electrolyzers, ME 450 1400. What does it mean, these numbers, 450 1400?
The 450, the first number is always the amount of hydrogen you produce per day in kilograms. So it's 450 kilograms of hydrogen production per day, and 1400 is the maximum power rating.
All right, okay, you have to know that. But 450 kilogram, which is quite good. How much would that be for a fuel? How many fuel cell bus could you power that?
I mean, a bus needs about 5 kilograms per 100 kilometer.
Oh, well, it's quite good, yeah. A really big one. And this PEM electrolyzers you just have sold to Greenpeace Energy.
Exactly.
And what do they want to do with that?
In this project, it's about feeding hydrogen into gas grid. It's at a certain point, a grid connection point, where the windmills are shut down quite often, in terms of more than 50% in a year, and they use this particular grid connection point to take the energy from the grid, produce hydrogen, and feed it directly into the gas grid.
So Greenpeace Energy wants to sell virtually green gas.
Yes. Green gas, yeah. It's the Greenpeace green gas you can buy anywhere in Germany. Yeah.
We are talking so much about business cases in Germany for hydrogen, and I could believe this is already a business case. I know a lot of people who would love to have green gas.
Yeah.
If they have only gas.
Anyone can buy it today, and in this project, it's not refinanced in the first year, obviously, but after a period of time, which I don't know the exact amount. But it's at the end of the day, it's profitable for Greenpeace Energy to have their own hydrogen production and feeding into the gas grid. Yeah.
So this is just the start, and they think about scaling it up?
Exactly. That's just the beginning. They also try the technology, see how it goes, and they're also at some point limited by the maximum hydrogen in the gas grid. And this is currently limited to 2% of volume. And if there's no change in the near future, they probably won't do, like, let's say, 10 megawatt of electrolysis. Then they would need methanation.
Hieke, do you know why it is limited to 2 volume percent into the gas grid? I remember we had like about 50% of hydrogen in the gas grid, like in the 50s. That was no problem, and now it seems to be a problem over 2%.
It's a standard coming from biogas, and actually the hydrogen is considered as a biogas in this project. And basically hydrogen was a byproduct in biogas, but the regulations hasn't changed, so we're still limited if the regulation doesn't change to 2%.
As far as I know, it's only a problem if there's a CNG refilling station nearby, because the CNG vehicles, they don't want more than 2% hydrogen. But in some grids, there are no CNG filling station. Maybe you could scale up to 20% in there.
Yeah, true, but yet you don't really know where the gas is going once you feed it into the grid, because everything is connected in Europe. So it's probably, again, legislation that holds us back here.
But this electrolyzers is in the far north, on the border to Denmark, as far as I know.
Flensburg,
and these are windmills or wind energy plants that are, well, only producing 20% of the time.
Yeah.
This is it's a shame. It's a catastrophe.
It really is. And you asked me about efficiency earlier. In this case, we are comparing efficiency of 0 to 75. So no matter what we do, we are more efficient than anything that has been done in the past.
I think it's a scandal, actually, and very few people know about that in Germany, even in Germany, that in the far north there are so many windmills not being used. They could easily produce hydrogen with that. Another project that you have is your electrolyzer ME100. I've learned it produces 100 kilogram per day, 350. It's a little bit smaller, but it's just as good. It is used in the wind park of Eilhöft. This is very close to the Danish border, as far as I know, and it should produce hydrogen for fuel cell cars.
Yeah, that's exactly the aim of the ME100 350. It has been developed for the use in hydrogen filling stations, because 100 kilograms is about the amount you need for cars, basically for cars. Not for buses. There will be 4 buses. That's probably pretty pointless. But for 25 cars in a rural area, which is probably as much as you get in a day in refilling during the next decade. So.
And there, the interesting part is that these are windmills that fall out of the German EEG. So they will not be supported anymore, and they can't be repowered because they're too close to houses. Yeah. So they thought about what can we do with this energy here. We can't get it to the grid anymore, so what to do? So this is also a good application for green hydrogen.
Yeah, exactly. Else they wouldn't feed in at all power, and they would have just disassemble the plants, and hence it's their solution to prolong the actual good power plants, the lifetime of the power plants, in Eilhöft.
Your mother, at least for 60%, is GP Joule, and they just started a project, eFarm called, where they use like 5 of your smaller electrolyzers, 2 hydrogen filling stations, and they even bought 2 fuel cell buses to have application with that. Tell me a little bit more. It's also in the north, it's northwest, Nibel to Husum.
He's Nibel to Husum. And again, they had the electrolyzer set up to a wind farm because of the EEG and feed-in tariff problem, where they have a lot of, let's say, taxes on the power, which increases the hydrogen price. And since they are directly next to a windmill, they use the power on their own and have a limited, let's say, to 2 to 5 cents per kilowatt hour of power price, which transforms then into, let's say, times 50, so you can have a hydrogen price for like 253 euros per kilogram, and you know the prices on the filling stations are about 10 euros, and even if the hydrogen is transported to the filling stations, it's still profitable to the public transport sector, because in the mid-term it will be cheaper than diesel in this particular project, even without any more investment other than hydrogen-fueled buses.
So that's impressive. So the prices of your electrolyzers don't have to come down then?
Hopefully not, yeah, I don't know. But it will happen though, on the other hand, because we see there's a grip in the market. It's getting on. There are more and more projects. So and whenever something goes from, let's say, trial into steady production, there will be cost reduces.
Sounds good. Are there any questions here from the audience? Please raise your hand if you have a question. I come with your microphone right to you. I'm thinking about, Mr. Hieke, there's so many solar panels in Germany who are just close to getting out of funding from EEG. And many people say, well, I would like to use this energy, and not only at daytime when the sun is burning, but also at nighttime. And my battery in the cellar is just a small one, and I would like to have a seasonal storage system. So why don't you sell your stacks to those guys who look for a storage system for their homes?
Oh yeah, you're talking about residential.
Right.
Because in big power plants, they also will run out of feed-in tariff in the mid-2020s. And then the same as with the wind, you can have big plant next to it, produce hydrogen in daytime. But in households for customers, consumers basically, we have a lot of requests to do that, but we decided not to go into the consumer market. We want to stay business to business. And but we supply our PEM electrolysis stacks, the core component of the electrolysis, to the market, to companies who are willing to invest in their own small household electrolyzers. So then we're going back to OEM supplier.
So these kind of systems you are not offering, but
No,
the
yeah,
stacks for the manufacturer of the systems, of course. Okay. Let's come to your new investor, which is quite an interesting story indeed. It is MAN Energy Solutions, former known as MAN Diesel and Turbo, a manufacturer of large diesel engines.
Yeah.
It's quite impressive that they took 40% of your company now. Obviously, the diesel world is waking up, or what would you say?
I'm not so sure about this. It might be true at some point, but however, they also have power, let's say, methanation in their product line, and they're going towards e-fuels, which is also again then can be used in standard combustion engines, and so they. For any kind of methanation, they need hydrogen as a part. So they said, well, we want to have the whole value stream again and go one step further to production, which is then hydrogen, and H-TEC Systems is a supplier of electrolyzers for that.
So they still keep to the internal combustion engine, especially for large engine, which is for ships or big power generation.
Yeah.
But they say we need a renewable liquid source, and that could be e-fuels. Yeah.
True.
And e-fuels are made by hydrogen. This would be green hydrogen plus some methane.
Yeah, exactly.
Okay. All right. So what are the biggest hurdles to implement electrolyzers into a business case like you have in Schleswig-Holstein e-Farm project? Is it that you have to pay the fees and the duties, or what is the
fees
problem?
and duties are a big issue to have a working business case. I mean, you have a power price in Germany roughly about 3 cents, 2 to 5 maybe, and then there are fees and duties which are 10 cents. And you can imagine if you get rid of these fees, your price will quadruple. Sorry, will be a quarter of what it would be if you buy the power from the grid.
Yeah.
This is one thing, and another thing is which really like holding us back in Germany at least is the so-called BIMSCH.
Yeah.
So you need a permit to operate
the certification
electrolyzer certification to operate an electrolyzer within Germany. And this just holds us back by a time span of at least 6 months. Usually it's more like 9 to 12 months from the time where we could operate the electrolyzer to when it actually is set up and
that's the problem with the early adopters, you know. They have to go through that. The second or third will have it easier, much easier indeed. But that's a big issue at the moment. Mr. Hieke, we run out of time, unfortunately. I would like to invite everybody here to visit the booth of H-TEC Systems B52, which is just around the corner. B52 is the name of a bomber, isn't it? Okay.
No
Very
bombs,
powerful name.
No bombs in our,
okay.
in our booth.
No bombs in our